Hey everyone, welcome to the webinar series by Devtron. Let me add Simran on the stage. Hi
Hi
Simran,
everyone.
how are you?
I'm good. How are you?
I'm also doing good. Excited for the webinar?
Yes, absolutely. Are you guys excited or not?
Let us know your excitement in the chat section. And good morning, good evening to all the folks joining in from different parts of the world. Really excited to kick this off. And I'm Akanksha Basin, your host for the day. And for those who are new to Devtron, let me tell you what Devtron does. So, we are an open source software delivery platform for Kubernetes application that improves the productivity and well being of developers, DevOps professionals, and platform engineers. So, with Devtron, platform teams can elevate their developer experience, shorten their release cycle, and also stabilize the production environments. We provide a seamless dashboard. So, with a single pane of glass, you could do all the things and freeing all the teams focus on their talent. They can focus more on the competitive advantage. So, yeah, now let's get started. And something about Simran. So, Simran is a cloud engineer at SIRS. Her expertise lies in specializing in architecting and implementing cloud solutions on GCP, Microsoft Azure, and AWS. Simran is not just an expert in cloud engineering, but also a mentor, public speaker, and a trailblazer in the world of cloud technologies. She has been a seasoned speaker and has spoken multiple events by the Google developer groups. Excited to kick this off?
Yes,
And
sure. So let's get started. Okay, so today we are going to get started with the unlocking of secrets with security and policies. Most of you have been already done or gone through Kubernetes and its security, the security context, its different level of security that we follow. But today we'll try to do something different, or even if we do the same things, we'll see what else there is. What are the basic criterias to follow the security systems? So, hi, my name is Simran Rajhans. I work in Sears Inc. as a cloud engineer, and I've been working there for past 2 years. I've also been doing Azure, AWS, and GCP as well. So today's agenda would be introduction to Kubernetes security and policies. Then what is the importance of security policies? We'll go through two types of policies. That one of will be gatekeeper policy and the other will be pod security admission. That is a Kubernetes native tool. Then we'll see some examples. I have tried to set up a demo for you guys, but just hope for the best that it works. Then we'll see the comparison between the two policies and then the best practices, and then we'll go for a Q&A and discussion. Okay, so um, most of you, if you have gone through the Kubernetes security, I read somewhere about the 4 C's of Kubernetes policy. That was cloud, cluster, container, and the code. So the cloud security in the context of Kubernetes involves securing the cloud infrastructure where Kubernetes clusters are deployed. That includes configuring cloud specific security settings like managing access control to cloud resources and addressing security concerns related to the cloud platform that is used, whether it is Google, Azure, AWS, whatever it is. Then the second level is cluster level security. It focuses on the overall security of Kubernetes cluster. That includes securing the control plane components, implementing role based access, then monitoring the cluster for security incidents, and performing regular updates to patch vulnerabilities. Then we have container. So the container security, it pertains to the security of containers themselves, like ensuring that they are built from trusted images, regularly scanned for vulnerabilities, and then they run with appropriate security settings for minimizing the risks. After that, we have the code that represents running with the proper containers in the Kubernetes environment. It involves like securing application code and ensuring that it follows the security best practices to prevent vulnerabilities and exploits. So this 4C framework provides a structured approach to address the security concerns at various levels in Kubernetes environments, from application code to the cluster infrastructure and cloud platform on which it operates. I hope I was pretty clear about it. So this will be needed in gatekeeper policy as well as in the pod security policies to get understand on what level it works. Okay. So the importance of Kubernetes security and policy is that it does an enforcement that are essential for safeguarding containerized workloads, compiling with regulations, preventing data breaches, maintaining the operational efficiency of Kubernetes clusters. As organizations are increasingly relying on Kubernetes for their applications, and Devtron also works with Kubernetes, so they must be knowing that a robust security strategy is a fundamental to ensure that the stability and resilience of these environments are important to be keep updated with the security policies, up to date security policies. Yes. So the challenges that are addressed, it is about the container isolation, that it addresses the need to isolate containers from one to another, that preventing potential vulnerabilities from one cluster to affect another's. Then there is network security. Network security policies help control and segment all the network traffic between pods, enhancing overall network security. We have then access control, which is role based access control, and it ensures that only authorized networks, if you have seen that we can create a public cluster or a private cluster, with private cluster and not being able to give the external IP, we definitely give the authorized network and the range of that network or the range of that IP, so that it can get access to the cluster, that basically process it and perform specific actions, and it reduces the risk of the unauthorized access. The vulnerability management, so there are a lot of tools, a lot of different cloud native tools, like Prisma Cloud is there, or some other tools are there which constantly gives a check marks that okay, this is the cluster, and this is the vulnerability that is being caught, or this is being good or not. So it keeps a basic, it is a security practice that regularly scans and updates to mitigate the vulnerabilities for both the Kubernetes platform and the containerized applications. Now we'll get started with the first one, that is our gatekeeper policy. So it is an tool that enables you to audit and enforce policies to Kubernetes resources. Gatekeeper is basically an open source tool, and these policies are written in a language called Rego. So it helps us to enforce the standards on resource across the entire cluster by rejecting the creation or update of any resource that do not conform to our policies. Suppose if we have a security context that we define under the spec of a container, and we want to give that it should not have suppose allow privilege escalation, it should be false. We do not want to give the container of allowing the privilege escalation, so we'll deploy a policy, we'll apply it to the cluster, and then we'll see that okay, if we create or update any new pod to it, then it will be created or not. So if it does not conform to our policy, then there will be several kind of standards, like we can deny the pod, we can then just give a dry run to the creation of the pod, so it will give us the violation, that okay, this is the violation, it has given, the user has given allow privilege escalation as true, so it will not get deployed. Then some of you might be thinking that what is the first logo, like the bullhorn. that is seen here. So it is known as open policy agent. It is the base core of Gatekeeper, and it is an open source general purpose policy engine that unifies policy enforcement across the stack. OPA provides a high level declarative language that lets us specify policies as a code and simple APIs to offload policy decision making from our software. And we can use OPA to enforce policies in microservices, Kubernetes, CI/CD, pipelines, API gateways, Helm charts, GitOps, and many more. So in Kubernetes, OPA uses the admission controllers. Okay. So, Gatekeeper works as an admission controller in Kubernetes. Okay, it plays a very crucial role. So, admission controllers enforces the policy on objects during the, as I said, create, update, or delete operations as well. So, admission control is a fundamental to policy enforcement, and in the Kubernetes API server, as you can see, it is configured to query OPA from control decision when objects like pod services that are created, updated, or deleted. Okay, and then the API server sends the entire Kubernetes object to the webhook, if you can see there, request to the OPA. Then OPA evaluates the policy that it has loaded when the admission review as OPA gatekeeper, and the following on the top of plain OPA, like an extensible parameterized policy library, it is there. Then all the gatekeeper policies, it is not like a user defines it specifically. We can create a customized gatekeeper policy, but all the gatekeeper policies are there on the official gatekeeper website. From there only you can directly check the policies for which gatekeeper is supported or not. Then there is the native Kubernetes CRDs that for in instant, it is like constraints. So there are two things in gatekeepers. One is constant template and another one is constant. So the constant templates is the policy library where we define everything, just as I said. Allow privilege escalation, it should be set as false. So in the constant template we define the logic that it should be go as false only, and in the constant we'll set up a push, just like cloud run, we will set up a push for the constant template that okay, this constant will run the constant template for non allowing of the privilege escalation. This is the basic functionality of gatekeeper, which run as a admission controller. Okay, so this is the architecture. This architecture basically says that we deploy the gatekeeper on the cluster. We'll do it like in the demo session. And then once we deploy it, it creates a CRD for constant and constant template as well. We'll go through that. So the gatekeeper base core is OPA, as I said. Then it runs as a admission control in the Kubernetes. Once it is done, then the constraints and constraints template, as you see, they both are run. So whenever we try to create a pod with the spec, the security context, then it goes through the constant and the constant templates. Then once it is validated, it goes to the pod, then deployment, service, ingress, whatever it is, whatever the Kubernetes objects are, it goes through that. Once it is checked and validated, if the policy is not compliant to us, then it will throw in violation if it is on denial mode. If not, then it will be created, but it will still give the violation to us that okay, hi, you are the user, and you can just customize that message. You are the user, and we do not allow privilege escalation, but you have enabled it. So instead of directly denying to it, we were in a happy mood, and we gave it to you like okay, you can just deploy the pod, but keep in mind and go and change that allow privilege escalation to false. Okay, so this is how it works. Okay, So we'll go through the smallest workflow. As much as I explained before, we'll go through that, okay, how it works. So the resource creation or update is there. Then it goes to the admission control phase where it checks the CRDs and everything. Then the gatekeeper policy evaluation comes in phase where it checks the constraints and templates with the next phase. And then if it complies to us, in the security enforcement phase, it checks that okay, it is working fine, it is validated. If the policy is like violating, then it goes to the policy violation detection. If it is in denial mode or if it is in dry and earn mode, then it will go to the violation prevention mode where you will see kubectl get violations, kubectl get constraints. You will get to know that okay, this is the constant, this is the number of violations, and you will get the describe the whole detail message that okay, where in which namespace or which pod it is violating. Then the resource deployment happens. If everything is fine, good to go, then the resource will be deployed. Then it is audit and logging, the pod is healthy or not, all the logging phases that are there. And then it is like continuous compliance, it will keep checking every time it is getting created or any resources updated. So this whole goes in a circle. Okay, some of the gatekeeper integrations that I specified in the start of our session, it was like Kubernetes cluster, in which it works like admission controller. Then in cluster policies, which we define the gatekeeper policies there. And the Kubernetes resource checks, it keeps on checking the resources. Okay, Helm charts, it integrate with Helm charts, which we'll do. And then the policy enforcement happens when after the Helm chart compliance is done and it the gatekeeper policy is written in the Rego language integration. Okay, next we have is CI/CD pipelines. In this, we were discussing with our teammate Abhishek, and we actually like discussed it thorough that what happens when the gatekeeper policies are done in the CI/CD pipelines. So, in the CI/CD pipelines, if you know, there whatever microservices are getting deployed after that get pushed, then in the CI/CD pipeline it is defined like it goes without any hustle. We just define the gatekeeper policy, like the constant and the constant template within the CI/CD pipeline, and it happens. We don't have to create three-step difference and then just go to like round and then it will happen. But it directly mm, uses that flow only. It's just that we need to define that gatekeeper constant and the constant template, and it will get deployed. Then it is the continuous compliance and automation in CI/CD. So the next is GitOps tools. It uses gatekeeper can also integrate with the Git repository policies. Automated compliance check is there, and the GitOps flow integration is also there, like Argo CD, and gatekeeper can have a lot of different integrations as well. So I was going through Abhinav Dubey's blog on Kyvernos that is integrated with Devtron, and they were having a compliance check and security policies with Kubernetes. So that as well. So Gatekeeper is one of the open source tool. The another open source tool is Kyverno, which we already have on the Devtron blogs. You can go and check. Yes. So now, pod security admission. The pod security admission is a Kubernetes native tool. Okay, so before, like, I'll just give you a history kind of lesson here. Before the pod security admission, there was one term known as pod security policies. It was there before the version 1.24 or 1.25, I might not be correct, but it was 1.24. So it used to uh, derive a CRD whenever we used to give pod security policy, and then we used to define certain constraints. It was, as it was a native tool, it was just too baseline and restricted, and then it used to give the policy for deploying, like it needs to be deployed or it does not needs to be deployed. That restriction was there. So now, after the version 1.24, we have pod security admission, that is a new native tool for Kubernetes, and its base core is gatekeeper only. So if you go and check the Google documentation, they have stated that the policy security admission has the base core as gatekeeper only. And using pod security admission, the cluster administrators can impose limits on pod creation. For example, the types of volume that can be consumed, or the Linux user that processes runs, to avoid running things as root and more. And so it is a cluster level resource that controls security sensitive aspects of the pod specification. If you can see, this chart is there, like what does the PSP do? It already restricts. And then the pod security policies, it also defines a set of conditions that a pod must run with in order to be accepted into the system, as well as default and the related fields of Kubernetes. The pod security admission policies, that are the controls, it is also there on the official website of Kubernetes. You can see on which part you can give the restriction, or in which part you cannot. So there are three kinds of standards which are followed by pod security, and it is categorized as privileged policy, baseline policy, and restricted policy. So the privileged policy is the least restrictive, offering a wide range of permissions. It allows for non-privileged escalations, which makes it less secure. So if you're just testing it, privilege policy is okay, but it is not recommended for or dev or prod environments. Then it should be always used sparingly with caution, and typically specific use cases, like where uh, only some privileges are necessary and the risks are well understood. Okay. The second one is baseline policy. The baseline policy, it is moderate restrictive, and it aligns with the default and minimal pod configurations, and it is designed to prevent non-privileged escalation and provide safer option than the privileged policy. It includes some of the baseline restrictions that can be defined. And last is restricted policy. So it is most of the restrictive policy that pod security admission offers, and it follows the best practices for hardening pods as well. But still, it will not give you the cluster level of security, because it offers high level of security by minimizing the potential vulnerabilities, and it is ideal for critical workloads and environments where security is a top priority. That ensures a robust defensive against potential threats. And while choosing pod security standard for your GKE clusters, it is very important to consider your specific security needs, risk tolerance, the nature of your workloads, and the restrictive policy offers a highest level of security in the pod admission, where the baseline provides a reasonable compromise between security and flexibility, and the privileges of, like, just like that, like whenever it is required. Okay, so these are the labels. Just try to remember these labels. Okay, because when we will be doing the demo for pod security admission, we'll use these labels only. Like, these will be the labels which will follow. So Kubernetes basically defines a set of labels that you can set to define the predefined pod security standards which you want to use for the namespace. Suppose if we are creating a namespace named baseline and another namespace as restrictive, so any of one of these labels we can use. So on what criteria we'll use these labels is, like, the first one is enforce, then the audit, and the warn mode. In enforce mode, the pod security admission controller, it is set to enforce the specified pod security standards, where the pod policy violations are treated with very strictness. Okay, just like being the principal. So it is treated with very much strictness, and if the pod security creation, like, the request doesn't comply with the standard, it will get rejected, just like your leave applications. Okay. And the audit event, it is also added to the audit log for monitoring and record keeping purposes. And this mode ensures a high level of security and policy adherence in the audit mode, whereas the focus is on monitoring and the recording of policy violations while blocking the pod creation. And while when a policy violation occurs, it basically triggers the addition of an audit event to the audit log, providing a record of that non compliance of the pod creation or the pod update. Then the pod creation is allowed even if the policies are not met. So, as I said, it will be a baseline thing that okay, it will be get created, but it will not be like it will have the audit log. Same whereas is the dry run in gatekeeper policy. Okay, these work as similar contexts. And in the one mode, it balances the flexibility with the user awareness of policy violations. And when a policy violation happens, it doesn't block a pod creation, but it allows the pod to be created. However, it also triggers a user facing warning that it notifies the user that okay, uh, it is being violated, so just take care of it. And this mode provides a compromise between security and flexibility, which ensures that the users are aware of the policy breaches but still allowing the pods to be deployed. Okay, another architecture, guys. Hi. So, when a pod is requested to be scheduled on a Kubernetes cluster via its API, it goes through a number of components before it is created. Okay. So, one of the components is admission controller. Admission controller is very famous in Kubernetes security, and you must be knowing why. So this component intercepts the request before it is persisted and in the etcd database and the resource being created. So admission controllers can be configured to use any web service, internal or external in the cluster. And through the pod security policies, it predates the modern dynamic admission controller. It operates in the effect as, like in some cases, it will not be valid for the pods that are already created, but it will be valid when the pods are getting newly created or are getting updated. So it will be done only on the new ones that is being created or updated. Okay. Huh. Theory time is over, so we'll try to have a demo now. I hope that the demo works. We'll first go with the policy. Okay, give me a second. I'll just share my screen. We'll start with the policy security, pod security policy. I'm sorry. Hmm.
In the meantime, if you have any questions, feel free to add in the chat section.
It got lost.
No worries. Take your time.
Yes, I'll just share my screen. Let me know if it is visible. Where it is? अरे यार, कहाँ गया? Wait, let me see.
Mhm.
Where am I? Um. Okay, which screen is getting shared? Can you tell me? I'm not able to see that. It is the gatekeeper one. Okay, wait.
Yeah,
We'll start with the second one first. I'm using Streamline for the first time, so it is just like that.
no worries.
Yes, no problem. Okay. Uh, okay. Which screen is shared right now? Can you just let me know because I'm not able to open it.
It's the same one.
It's
Which
the
is
PS one. Okay, okay. No worries. Fine. Okay, guys. So I have already. Huh, okay, it is working fine. I'm live, right? Yes. So we'll start with the pod security policy first. Okay. We'll create a baseline namespace, and then we'll also create a restricted namespace. If you want, I can share the links of the commands and everything, or the official links of the websites in the Devtron community. Now, if you see, I'll label it the namespace baseline with the pod security Kubernetes IO with one. As I said, the label it will be one for baseline. Okay, and for the restricted namespace, we'll go with the enforce as it gives the best pod security levels. Okay, so both the namespaces are labeled, and now we are going to do a kubectl get ns with show labels. Yes, so if you can see, it is one, the baseline one is one, and the restricted one is enforce. Okay. Hmm. Now we'll write a configured policy. Sudo vi psa workload dot yaml. Huh. This is the file, and the security context, it is given, the privilege escalation is given as true, which should not be true, it should be false. And we'll apply it to the baseline first, because we want only the violation and not. Yeah. Hmm. Okay, so we'll apply the workload to the baseline namespace. Yes, if you can see, it is a warning naming that it would violate the pod security baseline latest. It will be privileged that the container nginx must not set the security context privileged as true. So we'll just go and change pod security PSA. We'll give a false to this, save, and then apply again. Okay. Hmm. kubectl get pods hyphen in baseline. Yes, so nginx is running and it is fine. This time we did not get any kind of violation. So now we'll try to do same. Okay, I'll just change the thing I did. And we'll see the same for restrictive one. Okay, so it is giving an error from the server that while creating the PSA workload, the nginx is forbidden because it violates the pod security restricted and it is privileged that the container it is not there. Okay, and once we change it, it will get deployed there also. False. Why it is not getting applied now? Mm, mm. It's not false, but okay, we'll check it later. We'll have to check because I don't know why it is coming as this. Get odds restricted. Okay, no worries. That might be something that I've missed, but it works like this. So whenever we want, it gives an error that in the restricted ones it will give a violation, and it will not be created, and in the baseline one it will be created as we can see, but it will not like it will throw a violation to us that okay, this is the reason why it is not getting created. Okay, we'll try to move on with the second one. Okay. Share screen. Okay, I hope you can see the hand scratch here. Okay, we'll just start with installing uh, the pod. I guess this will also take time today. Okay, sorry guys, but I guess today the gatekeeper one will not work. It is not in the mind. So I'll try to write the blog and post the video on this, and I'll send it to the Devtron people so you can directly check their channel and see if it is working. Today it is not in a mood to work. The helm is not only working.
Yeah,
Okay.
no worries. Anish has one question. What's the demo all about? Can you explain more?
Okay, so the demo was basically, as I explained in the theory section, that while using the pod security, it gives us that while we are using the privilege escalation, if you are already, you know, gone through the security context of the pod security policies, the Kubernetes security policies in general, then you'll be seeing that there are some specific things that one should not allow, like the root user access should not be allowed to pods, or the privilege escalation should not be there, or it should not be run in a certain kind of namespaces. So with these kind of policies like pod security and gatekeeper, it helps us to prevent those things beforehand only. Like the pod security policies gives the policy about in at the pod level, which we can check. It is a native tool, as I already said. And the gatekeeper policy, it maintains the pod, cluster, cloud, all level of policies on the cluster thing. And then it helps us to not get not get that violation. So if it is on the uh, dry run mode, it will just throw us the violation that okay, your pod is getting run, but it does not mean that you are doing good. You have to write that, and you have to correct that thing in the pod and then run it again, so it will work. Or if it is in the denial mode, then it will deny that thing. So in the production environment, or even if you're in the dev environment, then the developers or the administrators, they try to use these kind of policies. So they'll just throw that violation thing on us. And as I gave you that restricted error, that okay, it will not, the pod will not get created because of this policy violation. And this is the thing that okay, privilege escalation is set as true, it should be as set as false, so you have to give this. I'll give you a short kind of comparison also between both the. Okay, yes. uh, hmm, Force. Yes. So if we can see the gatekeeper policies, it is an open tool, but it is highly customized policy with creation, and it is flexible. Because why I'm saying is this, because you can create the custom constants. Like if you are very friendly, you can just write the message, "Hi, your pod is running, but this is not how we work. So you should just go and edit your pod." Or if you want, you can just customize that message, that okay, what is the error, why it will be violated, why the pod will be violated. And meanwhile, the pod security policies, as we saw, it is flexible and customization. So the error, whatever it was shown on the page only. Like we couldn't customize it, we couldn't write our own message. Okay, in the gatekeeper one, we can write our message. The gatekeeper can cover various aspects across the Kubernetes resources. So from namespaces to the cluster level things or the pod level things, it can run on various aspects. But the pod security policies, it offers only a standardized ways to define security policies for pods and ensure the compliance with best practices. It runs only on the pod level, it does not run on the whole Kubernetes level. And if you compare both the policies, gatekeeper has more, like a lot more policies and the constraints rather than having the pod security policies. And pod security policy also uses gatekeeper at the core, like the OPA, but it still does not have all the features that the gatekeeper policy has. Then the gatekeeper, it benefits from an active and growing community from people who use Kubernetes. And it can be extended to enforce various policies. It will keep extending, it is still growing more and more every day. And as per the Kubernetes native solution, they are more tightly integrated into the Kubernetes ecosystem. And for the last one, gatekeeper can work on any cloud, like it is a third party tool, and it can work on Azure, AWS, and GCP. But if someone is here from Azure, they must be knowing that pod security policies does not work there. Like it is still not integrated with Azure, and it is not likely to come up in the next few days. It might come up later with some other versions, but it is not there right now. So if someone wants to try, I will post the links there, but you can see. And there are some best practices as well. So someone who is going to work with the security policies, they should, because the recommendations are very effective for the policy configuration. uh, it no, the privileges should be of least, like the principles should be of least privileges, as it helps of better security standards for production dev environment everyone. And in like being experienced person in cloud, I can say that many of our clients, like from start to end, they use tools not only like these, but to define like Prisma, or there are different kind of tools that keep on scanning the vulnerability, so that whenever it is caught, we are there to solve it and just prevent it from getting the data breach or having any kind of issues. So these policies are the beforehand thing of the scanning. This will, whenever you create that pod, whenever you do anything to that cluster, you will get notified. And the next best practices, like the regular policy reviews and updates are there. The utilization of RBAC and the namespaces are done correctly. The documentation is well defined and the communication is good to go. And the regular policy reviews and refinement is keep on going. The audit and logs are there. So it is recommended to use that. Okay. So do you have a lot of questions? Like, do you? Does anyone have it?
Feel free to put in the chat section.
Yes.
We'll take a minute or so. And thank you so much, Simran, for the well explained comparison between both of those. And the demo part also was also phenomenal.
I just wished if the gatekeeper
The second
was
part.
there, so it could be a better comparison throughout that. Okay,
Hmm.
I did not need to show the comparison page because people used to get the idea of with the demo only, but it's fine. No worries. Yes.
Let's wait for a minute or so. And in the meantime, I would also like to share more about the programs that we are running at the moment. I hope the screen is visible. Okay, so we are also passionate about open source and we are running Hacktoberfest program. So as part of that, you can also contribute to our open source repositories as well as you get a chance to write on your favorite topics, be it cloud native or something related to Devtron or DevOps. We also have a specific section in the use case section in our documentation, which is also open for all of you to contribute. So please check that out. And apart from that, I will be also sharing the link to the blog which I've written. And we are also running a giveaway on our LinkedIn and Twitter channel. So please follow us and participate in this giveaway. You will get a chance to win exclusive headphones and mouse as well. And we are there on GitHub, Discord, and LinkedIn and Twitter. I will share these links in the chat section once again. And let's wait for 30 seconds or so for any questions. And I've also pinned the LinkedIn ID of Simran as well. You can connect with her, and if you have any follow up questions related to the webinar, you can ask her. I think there are no questions at the moment.
That's okay.
Okay. Once again, thank you so much, Simran, for joining in for our webinar series. We are really thankful for you to be a part of this series, and hopefully, we will collaborate soon once again.
Thank you for hosting me, and yes, hopefully we'll collaborate once again soon. Okay. Thank you so much, Defcon, for hosting me, and it was great to be a part of this.
Yeah, it's our pleasure. Thank you, everyone. Bye bye.
Thank you, everyone.